Hello. Now let's start our next problem involving the medians of a triangle. So, 7.17. Prove that the centroid of any triangle cuts each of the triangle's median in a 2-to-1 ratio, with the longer portion being the segment from the centroid to the vertex. Okay? So, we first want to draw our triangle. So, something generic like something that looks, plain, simple to work with. That could represent really any triangle. Now we have to draw the medians. So we want the midpoints of all the sides. Oh, not E, that E, and there we go. And draw the segments to each of the midpoints. And now label that centroid or point G. Okay, now we have our basic diagram drawn. Now I want to show that the triangle's medians are cut off by the centroid G in a 2-to-1 ratio. So for example, AG I want to show is twice as long as GE. Well, how can I show that? Well, in our previous problems that we worked with area. We determined that all the areas of these triangles were the same. And to do that, we came up with a lot of ratios of areas. So perhaps we should think of the same logic. Come up with some ratios of areas. Because I know if I'm just going to call their areas X. They all have the same area X. That's what we proved in the last problem. Now, if I'm working with AG and I want to show it's twice as long, I want to create a triangle that has, how do you say, a triangle with twice the area. So I'm strategically going to pick triangle. Let's do AGB. Why not? And the reason for that is because, well, when I make my ratio, I'm going a little too fast. When I make my ratio, whatever's on the bottom, I want to be just X, because I know that AGB has an area of 2x, which is kind of beginning to form that 2-to-1 ratio I want. And I want an x on the bottom to fulfill that ratio. Now, that also has to involve the side GE. So, what could I do? Well, how about the triangle? Well, I have really two choices. GEC or GEB. I'm going to choose GEB because it's actually going to make some of the simplification very easy. So we have GEB. And those areas do form a 2-to-1 ratio because the x's will cancel out. Now, that's all fine and dandy, but that only tells me that the areas are a 2-to-1 ratio. Well, how do I know if the actual segments are? Well, and a nice way to determine that is if I take this ratio, I can set up another equation, that being the actual formulas, 1/2 base times height. But I want to do this strategically so that I'm left with AG over GE. Now, in our triangle, AGB, I can claim that AG is the base. I can claim any of these sides are the base of the triangle. But if I claim AG is the base, then that's going to be that larger portion of the median that I want. Now, what would the height be? Well, the height then, if AG is over here, the highest point would be B. So I need to draw a line that's perpendicular to the base from B. So if I click on B and draw the line from AG, that line's perpendicular. Now it looks a little weird, but again, kind of like we did in the last problem, if we just extend AG a little bit, we can see how that would fit nicely with what we want. Just imagine it extending out. This obviously forms our 90-degree angle because it's perpendicular by definition. And it is just an extension of AG. So if I called this, I don't know, point M, then my height would be BM. Now I want the ratio for GEB. Well, again, I want the smaller portion of the median, GE, to be in my problem. So I'm going to say that GE is the base of that triangle GEB. Well, then what's the height? Well, lo and behold, since it's on that same line as AG, GE and the height from B is still going to be the same BM, because it's still that height going from the top of the triangle straight down to the ground. So it's also going to be BM. And what do you know? This cancels out, and we are left with AG over GE. But this is the same as the ratio I started with. It's the area of AGB over GEB, which means that I also proved that that was equal to 2 over 1. So putting this all together, I have that AG over GE is equal to the ratio 2 over 1, which means that AG is twice the amount of GE. And that is the exact result that we wanted. And it is easy to prove this with the other 3 medians. It's just the same process we have just completed.